Hello everyone, my name is Rohan Bavishi. I'll be introducing our latest development in the AutoPandas project, which is the Gauss system. This was joint work with my wonderful collaborators, Caroline, Kaushik, and Ian. Before we begin the tutorial in this presentation, I want to introduce the problem statement for Gauss and give you a brief introduction of our tool, which should serve as a primer for the tutorial that is coming after this. I would like to clarify upfront that in this session, we will not be going over the details or the technical details of the system. The focus of this session is the UI itself. So let's begin. So in the past few years, in the world of data science, we've seen this explosion of APIs. In some sense, you have, for every stage of the data science pipeline, you have a dedicated API to do that task. And for the average data scientist, given the sheer size of the APIs and the dense documentation, it's unreasonable to assume they have adequate knowledge of a given API in order to complete their task without going back to the documentation and asking questions on Stack Overflow, just simply looking them up. And the nature of these use cases of these APIs are often one-off. For example, if you're plotting something for a report, the code you write, you might refer to documentation, gain some knowledge of the API for doing that, say matplotlib. But after you're done with the report, that code is probably going to be thrown away because it's very specific to that use case. And with that, what you learned about the API goes out of the window as well. So you have to keep repeating the same loop every time you want to use the API. So because of these characteristics, the general field of program synthesis has tremendous potential to improve productivity of data scientists. So how does this work? So at its very core, program synthesis contains a synthesis engine to which the user provides a spec detailing their intent or like what they want to do, which can be, say, an input output example. So let's say they want to perform a table transformation. So they provide an input table and the output table. And they ask the engine to come up with code that does this. And the engine comes up with code, say the one on the right, which is using the Pandas API for performing the table transformation. And the user can simply use the code snippet within their larger pipeline. And our first effort at this was the AutoPandas system for table transformations in Pandas. It's available at this link, so feel free to check it out later if you wish. But for the rest of the talk, I'm going to try and convince you why input-output examples for table transformations are maybe not the best option. In particular, they can be tedious, error-prone, and lossy. So let's see how that's the case. So let's say you are a synthesizer, for argument's sake, and a friend comes to you with this input-output example and asks you to write code to perform this task without any other instructions, just the input-output example. So you would be left wondering what is actually happening. So for example, what is 121? How is it being computed? And it would take you a while before you figure out that's actually the mean of 25 and 217, and there's some sort of aggregation going on. But this was a fact that was known to your friend because otherwise they would not be able to provide the full output in the first place. And because of the nature of input-output examples by themselves, this important information is lost, and you as a synthesizer now take more time to come up with the solution because you have to figure this information out by yourself. What's even a bigger problem is in terms of providing the input-output example, the burden of actually providing the complete output is quite a bit. For example, in this particular case, specifying the output may actually decrease productivity of the data scientist because there are so many values that you need to compute and actually specify, during which you could always just look up the documentation and write code yourself. So this definitely does not improve productivity. So what does our solution do at its very core? We do not throw away the rich information about the underlying computation. And we allow the user to specify partial outputs instead of full outputs. So the first one improves the speed of synthesis. We can utilize the information to search faster. The solutions themselves are of higher quality because they match the desired intent of the user better. And because we're accepting partial outputs, it improves productivity because of less burden on part of the user. So to give you a taste of how we're doing this, essentially we provide the user with a UI, which displays the input and gives you space to provide a partial output. And you can build the partial output incrementally by performing certain operations. So for example, you can copy paste values. So let's say I copy paste beer over here. This internally records the fact that the beer in the output is actually equal to this particular column value. Similarly, for aggregation, I select 25 to 17, select the mean operation explicitly, and then copy it over to the output. So now the system is aware behind the scenes that 121 is actually the mean of these. So we're not throwing away that important information. And this as an output is enough. We allow the users to specify just this. And once they click synthesize, we are able to come up with a completed solution. So you have the table over here containing the complete aggregation, and you have code as well. So you can simply, the user can simply use the code from here in order to perform their task. So in the tutorial itself, we'll learn how to use the UI, cover the basic mechanics, and we have some exercises for you as well to practice using the UI. Hope you have fun. Thank you. Welcome back, everyone. We are now going to begin the tutorial. So at this point, I assume you were able to use the Docker setup or are using Binder to access the notebook that I'm showing here. So before we begin, I would like you to execute the first cell because this might take a while. And it's a good idea to keep it running while we go through the introduction. So go ahead, execute the cell. It will show a bunch of messages, but you don't need to understand them. So in the previous video, I already introduced the system, so I won't go through it again. But I would like to mention that the tool is very much in an alpha state. So if you have any feedback, that would be very much appreciated. So feel free to reach out to us on these email addresses. So let's begin. The first part of the tutorial, I'm going to introduce the tool itself, the main components that you should know in order to do the exercises that follow this section. And the first section of the notebook essentially contains all the documentation that you need, starting by the anatomy of the interface itself, detailing the main components of the UI. So here you see three major regions of interest. The first is the input itself. So the input part of the specification is displayed as a table here. Yeah, you have a table editor for specifying the partial output. In this case, you see low and high in a single column. You have synthesize and reset buttons, which do exactly what their name suggests. If you click synthesize, the specification is passed to the system, and the system comes up with solutions that are detailed over here. So you see a code snippet containing executable code with the correct variables. So if you use df here, it's trying to use the same thing. And the result of executing this code is shown over here in this table. If there are multiple solutions, you can cycle through them by pressing pref and next. There are some other things as well, but let me explain them as we go along. The next major thing you need to know is about using the editor itself. If you've used Excel or Google Sheets before, this should be really easy for you to pick up. We try to use the same mechanisms as in those user interfaces. And the three major types of interaction with the editor that you need to know about is essentially cell selection, selecting cells, copying and pasting values over, and performing operations on a subset of cells. So again, as I said, this is more of a documentation. So feel free to refer to this in case you need clarification or need to refresh your memory. We also have GIFs of the main operations that you need to know. So hopefully this makes it easy for you to pick up these controls. But what I'm going to do now is go through an example detailing all of these concepts, and hopefully this will serve as a good introduction to the controls of the UI. So let me get started and spin up the interface. So first I'm going to create a data frame in order to use the UI. So let me go ahead and execute this. Feel free to follow along, by the way. So we have a data frame, doesn't matter what it is. It's good for example purposes. So let me spin up the UI by executing this up. So here you see the input, and just in a more fancier format, and you see the editor for specifying the partial output. So let's begin. The first part was selecting cells. So selecting cells, you click a cell, it changes its color. You click it again to deselect it. Similarly for column cells. I would like you to know that you do need to click the cell again to deselect it. Clicking anywhere else won't do it. If you want to select multiple cells, simply use mouse drag and drop. Select the range that you're interested in. And then simply use mouse drag. It will be a continuous range. And if you want to select multiple ranges of cells, simply hold down the command button or the control button if you're in Windows to select those cells. So for example, this, I'm holding down the command button or the control button, and it simply just keeps adding to the ranges of cells selected. So this allows you to select any subset of cells that you're interested in. So that's about it for selecting cells. Let's look at copying and pasting. So copying, pasting, that's simple. You click a cell, you copy it to the clipboard using Control-C or Command-C. You click on the cell in the output where you want the value and simply paste it. That's it. Also, as an aside, you can always click reset to, just reset everything. Now, if you want to copy and paste multiple values, simply select the cells that you want to copy over using the selection mechanism. Copy it to the clipboard, and in the output, select the cells where you want to paste it. So in this case, let's say I want it horizontally instead of vertically. So I simply select these 3 cells and paste it, and voila, you get the cells over there. What I would like to mention is that the order in which you select cells is pretty important. So let me demonstrate. For example, I want to copy 70 and 50 over in a single vertical fashion, but I want 70 first. So in order to do that, I will select 70 first, then 50 using the command option. Sorry. So I copy it to the clipboard. Sorry, I need to do that again. So I'm clicking 70 first, then I'm clicking 50, then I'm copying it to the clipboard, selecting the cells in the output, and I'm pasting them, but 70 is coming before 50 because that's the order in which I select the cells. So you need to remember this will come in handy for one exercise. So that's about copying and pasting, as simple as that. And the final thing that you need to know is performing operations, because not everything is just copying and pasting values. Sometimes you need to do operations such as aggregation, for example, right? So let me reset again. So in order to perform the operations, you simply select the cells on which you want to perform the operation. For example, you click these 4 values. You click right click, and it reveals a context menu containing all the operations that you can perform. Simply select the one that you're interested in. For example, I want to take the average of these 4 values. It copies the result to the clipboard. It shows you the message over here. And then you can simply paste the value wherever you want in the output using paste, right? So very simple. There are some other operations as well, and you have GIFs on before this section in order to. So if you're confused about any of the operations, you can refer to that. And the final part of using the UI is actually synthesizing something, right? We've learned how to specify the partial output. Now, how do we use the UI to actually produce code that does the transformation that we're interested in? So let me just reuse this example. We've already computed the mean of these 4 values. Let's say this is something I'm interested in for some reason, right? So let's go ahead and click synthesize. So this passes it to the system, and the system comes up with this following solution. You see the completed table here where you have 77.5 associated with pants, and you have a value for shirts as well, which is 95. And you can click on this cell to reveal how it was computed. So in this case, 95 is the mean of 110 and 80. And the cells in the input that are responsible for this are being flashed in green. Similarly for 77.5. So this is a good way to verify what is happening and whether it meets your specification. And if this is a table that you're interested in and you want the code for that, you can simply copy paste this. It already uses the correct variables and the arguments, so you can use this as is in your script. All right, so that's about it for using the UI. Feel free to play around with this section. And in the later part of the tutorial, we'll go through some exercises where I try to use the UI to do some meaningful tasks. And we have some practice exercises for you as well at the very end for you to really double down on the various components of the UI. Thank you very much. Welcome back. In this part of the tutorial, I'll walk through a couple of examples for you to show you how to use the UI to perform some meaningful tasks. We have a couple of them lined up. And after this section, you'll have practice exercises for yourself in order to hone your skills in terms of using the UI. So let's begin. So the first task is something very simple and very common. It's about aggregation. So what your task is given a table such as this, you wanna write code that produces an aggregation that sums up the population by the region. So in this case, you're summing up 950 Naya 32, which is becoming that region. So very simple, something that many of you might be already familiar with. So let's try to do this task. So let's create the table, which is actually like a concrete data frame. And then let's start the synthesis UI. So you see the input over here. So what we want to do is do a summing of the population. So let's do that. So I select 950, 32. I select the sum aggregation, copies to the clipboard. I paste it on to the output. And that's actually it. This is enough of a signal for the system to figure out what I'm trying to do. So let's see what it tries to come up with. So let's click synthesize. And the system does the task correctly. It has an entry for Miss Stalin as well, not just Cantor, and it uses the group by and sum function. So for those of you who have used pandas, this is something that you would probably already be familiar with, but this is a good introduction to what the system can do. So you didn't need to provide any more of the output. Just one cell was enough. All right. So try this out for yourself. For every exercise that we have this show hints tab. So it kind of contains the crux of what I just said, some hints, and it also has a GIF of sorts detailing how to go about creating the output in case you're stuck, but kind of need to revisit things again. So that's the first demonstration. Let's move on to something a bit more complicated. So let's move on to task number 2. So what you see over here is a table detailing low and high prices for a product. And what you want to do is produce a table that contains the price range in some sense. So the range in itself is simply high minus low. So you have 50 over here, which is 90 minus 40, right? But you want something else as well. You want that the output should not contain the low and high values. It should only contain the product and the range. So you want to essentially delete the low and high columns, right? So these are the two things that we need to accomplish. So let's get started. Again, create the data frame, start up the synthesis engine. And let's do the subtraction operation first. So I want to subtract 40 from 90. So remember the ordering in which you select the cells. That's important. So that's going to come in handy here because you don't want to do the subtraction the other way around, right? You do not want to subtract 90 from 40. So the order of cells matters. So what I'm going to do is I'm going to select 90 first, then I'm going to select 40. Then in the context menu, right-clicking, you see binary operations sub, which is subtract. So once you do this and you paste it over here, you get the correct value 50. All right. So let's go ahead and synthesize. This does contain the subtraction operation that we needed. So the system comes up with the solution. It does have a column sub high low, which contains the ranges. And the code uses the dot sub function. But again, as I mentioned, this is not completely what we want. We want to get rid of the low and high values, right? So we need to achieve that. So there are two ways to go about this. The first one is to go back to the original thing and explicitly specify that you delete the low and high columns. This is something perfectly fine, and you can then just click synthesize to get the updated value. But I'm going to try something else at this point. So at this point, you may realize that this is not actually wasteful. You have achieved something meaningful. It's just not exactly what you want to. So on top of this, you want to delete the columns. So you can start up a new synthesis problem where this output now becomes an input. So in a sense, you're trying to break down the problem into two different synthesis problems and achieving both of them separately. So let's try that out. So I'm going to use click use as input. So what you see now is a fresh UI instance where you not only have the previous input, but you have the new output as an input as well. So you have another table here with this range column. And now what I'm going to do is actually signal that, on top of this, I want to delete these two columns. So right click again, mark as deleted, and then I click synthesize. So you didn't need to really specify more of the output. All you were interested in is deleting some part of the input, right? So the system now comes up with the table that you actually wanted. But what's interesting is that it remembered the code it synthesized from before and combined it with the new code. So this has the subtraction as well, and then the new drop function. So now you can use this code to get from the original input to this final output directly, right? So this is how you can use as input to break down the problem into multiple problems. All right, so again, we have a hints tab detailing whatever I said, and then the core hints that would help you go about this in case you need to refresh your memory. So these are the two tasks in order to demonstrate how to use the UI to perform meaningful tasks. After this section, I will introduce two practice problems for you where you can use the UI to perform the internet transformation. Thank you very much. Hello, everyone. In the final part of the tutorial, we have some practice exercises for you, and I'm just going to quickly introduce them for you. So in the first exercise, your task is to, given a table containing, say, some metrics for quantities, say for years, like y1, y2, y3. And you want to reshape the table somehow. You want to write code for that, where the new output now contains a single column containing the years, like y1, y2, y3 in a single column. And the metrics themselves become the new column. So you can think of this as a transpose, but it's not quite that. So you can execute these two cells to start at the thing. So get cracking. Try to synthesize code for this, and you can always refer to the hints if you're confused about something. The next exercise is the most challenging of the lot, and it introduces a new operation. So what you have is a table containing some measurements for plants, where the columns themselves combine the day and the week information in a single string separated by underscore. And what you want to do is something quite sensible. You want to separate the days and weeks into two separate quantities, and you want to have two columns containing them. And you want to retain the plant column and rearrange the values or the measurements accordingly in a single column as well. So in order to do this, you will have to use something called a string split. operation, you should be able to find that in the menu of operations. And again, if you're confused about something, feel free to refer to the documentation above or refer to the hints for this specific problem. Hope you have fun. You can always ask questions on Slack as well if you want to directly reach the TAs. Thank you very much.